Okay, our first target today is going to be identify an indirect proof. We aren't going to actually do indirect proofs, but we do want you to be able to come up with what you would do to use an indirect proof, or when you would use an indirect proof. So first of all, the idea of an indirect proof is that you prove something is true by proving that it can't be false. Okay, so for instance, if I say like the first one, a scaling triangle cannot have two congruent angles. Okay, well, I could go through all the different kinds of congruent angles and prove it doesn't work, it doesn't work, it doesn't work, but that would take forever. What an indirect proof is, it flips it around, and then you just use your normal method of solving a proof to prove that it can't work. So for instance, I would take a scaling triangle cannot have two congruent angles, and I would switch it to be the opposite, or the inverse. A scaling triangle can have two congruent angles. Then I would go through the proof, okay, and eventually I would hit something that absolutely cannot be true. And then I would say, because this can never be true, the opposite must be true, which is a scaling triangle cannot have two congruent angles. For instance, so you'd go through, you'd prove that, you'd identify the conjecture. So in this case, the proof is that triangle JKL does not have an obtuse angle. Okay, so then I would try to prove the opposite. So in this case, it would be triangle JKL does have an obtuse angle. And then again, just like any other proof, it's easier if you have actual identifiable angles to work with. So let's say in this case, I'm going to say angle K. In this example here is obtuse. Okay. Our third step would be use good old regular proofs to prove that as far as we can, and hopefully hit something that's false. So in this case, I would say angle K, because angle J is a right angle K plus angle L must equal 90 degrees. That's the acute angles of right triangle theorem. Then angle K, if I just subtract angle L from both sides, I get angle K is equal to 90 minus angle L. Okay, then, so that's subtraction. Then I have the fact that angle K has to be greater than 90. That's the definition of an obtuse angle, because we just said angle K is obtuse in the given. Okay, then I can say 90 minus angle L, which is up here, right? And I'm substituting it in there. It's greater than 90, because I just said angle K was 90 minus angle L. Okay, which means angle L, when I subtract 90 from both sides, and then I get negative the measure of angle L is greater than 0, and then because it's a negative, I flip it and make it the measure of angle L is less than 0. Obviously, no angle can have a measure less than 0. So the conclusion must be that since the assumption is false, the original conjecture must be true. Okay, so by proving my inverse is false, I'm proving that my original statement was true. Okay? All right, so that's indirect proof. Basically, you just need to be able to, if these are the proof statements here, I just want you to be able to come up with what you would try to prove as your indirect proof. So if my statement is two obtuse angles cannot form a linear pair, stop and think a second about what the inverse would be. It would be two obtuse angles can form a linear pair. Okay? for the next one, if QR is not greater than QP, my my new inverse that I'm trying to prove would be QR is greater than QP. Okay? So you can identify those indirects. If you know that if it's going to be an indirect proof, it's going to have a not. Okay? You'll notice that every single one of these proofs that every one of these statements that I'm going to use an indirect proof with is going to have, it has a negative. A scalene triangle cannot have two congruent angles. An obtuse angles cannot form a linear pair. QR is not greater than QP. Okay, that tells me it's going to be an indirect proof. All right. The next statement is kind of common sense. If if you've got a scalene triangle, then the larger angle is always across from the larger side, smaller angle across from the smaller side, middle angle across from the side, sort of like the three bears theorem here. That is, so in this case, 17.4 is the smallest side, so angle C, which is across from it, must be the smallest angle. So if I'm writing these in ascending order going up, angle C would be first, then 28.5 is the next largest, and since angle B is across from it, angle B would be the next largest angle. And since 30.1 is the largest, the angle across from that side would be the largest angle. So in ascending order, smallest to largest, would be angle C, angle B, angle A. Okay, and the opposite is true. The smallest side is across from the smallest angle. So this is, first of all, I got to find the missing angle. So 31 plus 54 is 85. So that means this angle is 95 degrees. Okay? And so the shortest side, or no, these are, I'm supposed to write these in descending order. So I'm going to go largest to smallest. So the largest side is going to be across from the largest angle. Well, this is the largest angle. So the longest side would be xy. Okay? The second largest angle's here, so it's across from zx. And the smallest angle is here, so the smallest side is zy. Okay? Smallest sides across from the smallest angles across from the smallest side. Okay? Okay, the triangle inequality theorem is actually one we use a ton, and in math club, this comes up all the time. For a triangle to exist, the sum of any two of the sides must be larger than the third side. And we talked about this a little bit the very first day. If you think about these sides being on a hinge, being able to swing up and down, like up and down here. Okay, if this is 3 and this is 3, but this across is 7, these two sides could fall in and never touch, never meet in the middle. So they would not make a triangle. Okay, and that's kind of what this theorem is saying. These two sides always have to be larger than the third side. Okay, and even if they're exactly the same, like if I had my 7 and this is 3.5 and this one's 3.5, this one would come down and this one would come down and they'd meet and make a line exactly 7 long. So again, it would just make a line. So this side would come into here, this side would come into here, and it wouldn't be a triangle. Okay? So the sum, like this one, 4 plus 4 is 8. 8 is larger than 7. So these two sides, when they start to come in, they are too long and they hit right there and make a triangle. Okay? So you don't have to actually see the triangle to know. If if this is a triangle, then the sum of any two of the sides is going to be greater than the third side. So I always start with the largest side. 7 plus 10, well, that's 17. 17 is not greater than 19, so this cannot be a triangle. Okay? 4.6 is the largest, so I do 2.3 plus 3.1, that's 5.4. So that one is greater than 4.6, so that's okay. And then I can do the others, although it's always going to work. So 3.1 plus 4.6 is 7.7. That's obviously greater than 2.3. And then 6.9 is greater than 3.1. So that one does make a triangle. Okay? When n is 4, my sides are 10. And then n squared, 4 squared is 16 minus 1 is 15. So I've got 10, 15, and 3 times 4 is 12. So I've got sides that are 10, 15, and 12. And the largest is 15, so 10 times 12 is 22, and that's greater than 15, so that would also be a triangle. Okay? Now, if I want to find the possibilities, if two sides of a triangle have a length of 6 and 10, the range of possible lengths, well, we know that it has to be larger than the sum of these two. So it's got to be larger than 6 plus 11. So my angle measure, x, has to be bigger than 17. Okay? But now think of it the other way. This side here, 6, has to be larger than this. Wait. Okay, sorry. So 11, when I add these up, okay, there. 11, 6 plus the second side has to be greater than 11. So my second side cannot be less than 5, or cannot be less than or equal to 5. Okay? So x has to be greater than or no, not equal to, just greater than 5. So x has to be sorry, not like this is put the wrong sign there. It has to be greater than 5 and less than 17, because these two have to add together and be larger than 17, but it has to be at least 5, because 5 plus this second side has to be greater than 11. Okay? All right, and finally, we got the hinge theorem, which says if we've got two isosceles triangles, which, well, not necessarily isosceles, but that they're equal. So this side here is equal to this side, and of course, in this side is equal to itself. So in these two triangles, we have two sets of equal sides, these two sides and this side that combines for both of them. The larger side is across from the larger angle. So obviously this side here is larger than this side here, right? So that means this angle has to be larger than this angle. All right, so just the same way that 8 is greater than 7, then 25 has to be greater than 2x plus 8. Okay, and so to find the values that 8 could be, I just solve. So 17, I subtract 8 from both sides, so 17 has to be greater than 2x, divide by 2, x has to be greater than 8.5. So x has to be greater than 8.5. Okay? All right, we're not going to do that proof right now. Now, Pythagorean theorem, if you remember, a squared plus b squared equals c squared. Actually, we're going to do that tomorrow. Okay, We'll do that tomorrow. So your homework tonight is going to be the second section in the back of your target sheet, and it's in the book. So please bring your book.